So, Ernie, you were here last year, and you were speaking about how you were going to choose an engine and maybe look at some more partnerships. And you've had two big announcements in the last, actually probably the last 4 months. So you've chosen an engine. Actually, which would you like to talk about first, the engine or Lockheed Martin?
Good morning, everyone. I'm ready to talk about either. I think probably in sequence, in May last year we announced, actually it was GE that announced we'd selected them to provide our engine for the AS2. That's a culmination of about 14 years of work and research. We thought we had an engine way back, I think in 2008, the Pratt & Whitney engine, but we realized pretty earlier on that it wouldn't meet stage 5, which kicks in 2020. So we had to source another engine, and happily GE is the engine we've selected. The engine that we've selected is a variant of a current commercial aircraft engine that's got over 1 billion hours on it.
And you also announced a partnership with Lockheed, an old...
Lockheed, yeah. In December, we announced that we formed an alliance with Lockheed Martin Skunk Works of Palmdale, California. They're going to help us develop the airframe, I should say. And we're thrilled about that. We had a very good relationship with Airbus. It was a 2-year agreement. They helped us a lot with earlier design of the airplane, some proof of concepts that we had. And we're delighted to have finally agreed to develop the airplane through Lockheed Martin.
And do you know exactly what's Lockheed bringing to the project?
Boy, many engineers who know how to design supersonic aircraft. Lockheed Martin, over the years, have built more supersonic aircraft than any other manufacturer in the world, including, of course, Russia. So being aligned with them to help us develop this airplane gives us a lot of confidence that we're going to bring this aircraft to market eventually. First flight will be in 2023, and deliveries will begin in 2025.
So 2025 customer deliveries. Let's get back. How long has the Aerion project been going for?
2025 isn't that far away. I think many of the people in the room are still going to be around. I don't know how much hair I'll have left by 2025, but just to address your specific question, Alistair, our program has been going on for 14 years now. When I get in front of prospects for the airplane and I tell them that 2023 first flight, 2025 is first delivery, they naturally ask me, well, why does it take so long? Actually, when you think about it, 5 years in a development phase and 2 years certification phase is pretty aggressive. I recall our days at Embraer when we announced a Legacy 450, a Legacy 500, a relatively simple mid-size airplane, but with fly-by-wire technology. That took us 5 years to develop. So 5 years to develop a supersonic airplane really isn't that bad. It just seems to be a long way away because what the public has visibility to today is the development phase of the program, let's call it behind the scenes, what goes on behind the scenes before you formally announce the launch of a program. So it's really not that long. But the biggest challenge about the supersonic flight is, of course, the engine. And it's finding the right engine that has longevity and commercially available. And that's what we found with this GE engine.
Actually, we've got a question about the engine. Is your engine working with an airflow that's entering at subsonic speed, like Concorde?
Well, Concorde, of course, first of all, credit to the Concorde designers and engineers over 40 years ago. They didn't have the same challenges that we have today in terms of certification, noise abatement, ecological considerations. So the engine has always been the challenge, and the challenge about the engine, of course, is longevity. We want good times to hot section inspections, TVOs, those sorts of things. We want frugality of fuel burn up at altitude. But the real challenge is slowing the air as it goes into the engine, because once you reach supersonic speed, you have to slow the air going into the engine and then recompress it at the back end to give you the thrust that you need to exceed the speed of sound. Military aircraft, of course, use variable inlet nozzles or any mechanisms that they have for choking the air going into the engine. We don't want our engine and we don't want our aircraft being that complicated to fly. GE have found a way, and it's what I'll refer to as a secret sauce for the engine. Sauce being ketchup sauce, I guess.
Can we go through the S2 quickly? So, how much does it cost?
Well, if you say it quickly, it only costs $120 million in today's money.
But you are also offering 10% off today.
No, I'm afraid not. It's cheap at that price, Alistair, you know that.
I think it's good value.
And people do ask me, and in truth, I have to say, the sales pitches that I've made over the last couple of years, I'm not getting pushback at 120 million. People sort of nod their heads and say, yes, well, what does the airplane offer? And when I start telling them, for example, I arrived early this morning from Miami. If I'd have had an AS2 to bring me here, I could have saved 4 hours of flight time getting to Dubai from Miami. If you multiply that by the times somebody has to make a trip like that over a year, we did analysis for a Fortune 500 company in the States. We analyzed the flights that they did last year in 2017 and showed them in an AS2 we'd have saved them 145 hours of flight time in a year. That's 3 weeks of saved time that the executives could have saved. And that's why it's important. That's the next step for us. I think for us as an aviation industry, supersonic travel is coming, and we think we're the market leader, we'll be the first to market.
I'll come back to that. So, how fast does it fly?
Maximum cruise speed will be 1.4 Mach. Red line will be 1.5 Mach. And long range cruise, 5,300 nautical miles at 0.95. And an interesting factoid there, that at 0.95, we achieve 85 to 90% of a competitive wide-body cabin airplane in terms of its range. So if that airplane flies at 0.95, we achieve about 85 to 90% of their flights at 0.95 as well.
I've met your technical guys, and I'm sure they can make it go faster. Was that a decision not to go at Mach 2?
Well, I'm not an expert on supersonic flight yet, but I'm learning as I go along. One of the first things I asked engineers when I joined Aerion back in 2015 is why only 1.4 Mach? Well, as I said, red line is 1.5 or MMO is 1.5. The challenge to go through 1.5 is greater than the challenge to go through the speed of sound. When you get to Mach 2, it's quantifiably more difficult to go through Mach 2. And so if a designer is having trouble finding an engine to go through Mach 1, and we've been searching for an engine for 12 years, imagine how difficult it must be if you wanted to regularly fly in excess of 1.5 or even 2.0.
Another question from the audience. What will be the range at high-speed cruise?
At Super Cruise, which is what we call Mach 1.4, the range is 4,200 nautical miles in zero wind ice conditions. And at long-range cruise at 0.95, the range is 5,200 nautical miles.
This is like testing you on all the facts. What's the expected flight level or altitude?
Alistair, it's very early in the morning. This brain of mine.
And you landed at 3 this morning.
All these things I've got to remember. Well, at the moment we're targeting 51,000, but I do think the airplane will go higher than that.
Okay, more questions from the audience. Okay, the land question you knew was going to come up. Doesn't a supersonic aircraft lose its advantage when overflying land, such as Dubai, Europe, and being limited to subsonic speeds?
I thank you for the question. I get that periodically, and yes, the challenge is over the United States back in the Concorde days, in order to avoid the sonic boom over the contiguous United States. The FAA wrote the rule to say that there'll be no supersonic flight across the contiguous United States. Internationally, IATA wrote the rule, ICAO I should say, wrote the rule to say that there'll be no disturbance created on the ground by supersonic flight, so there's a small variation between the two regulations. What Aerion have done through its airframe and wing design is we've come up with a supersonic speed of 1.2, which we've called boomless cruise, and that is to say that subject to atmospheric conditions up at altitude and the distance between the airplane and the ground, the shock wave that hits the leading edge of the wing won't dissipate before it hits the ground. So that makes it a boomless supersonic flight at 1.2. The OEMs, Gulfstream, Dassault, Bombardier, all of the OEMs are meeting now on a regular basis with the FAA to discuss a change of ruling, at least as it would pertain to flights over the contiguous United States, because the FAA realized that supersonic flight is coming to our world in the near future.
You really are pitching this now, or being asked to pitch this. What's the average hourly operating cost?
Well, speed doesn't come cheaply. So we're predicting that the hourly cost will be something a little bit in excess of, let's say, a G650 or a Bombardier Global 6 or 7000, but somewhere less than a BBJ.
What about connectivity? Can you actually connect when you're going that fast?
Yes, you can connect as you go that fast. Yes.
So is it important to connect?
You know, it's important, and I think one of the things that gives me comfort, the owner of our company, we're privately owned by a gentleman in Fort Worth, Texas, Robert Bass. Robert Bass has been a user of corporate airplanes for decades. He knows what the customers want, he knows what he wants. He currently flies in a G650, I think he's still got a Falcon 900. So he knows what the customers want and their expectations. He knows about quality, fit and finish, and all the issues that an operator or an owner faces. And those goals are our goals, except we want to exceed them.
Still loads of questions. Why not a Delta wing?
I think if you look at Concorde, and for those of us who are young enough to remember when Concorde used to fly, I remember going to Farnborough Air Show, Paris Air Show, and seeing that airplane take off and land. It was a beautiful sight, there's no question about it. And that was a true Delta wing, but the issue with the Delta wing is that while it's efficient at altitude and high speed, it's inefficient at slower speeds. Many people don't realize Concorde used to be cleared to land into New York from London about 300 miles out. There was not a lot of room for a go-around in Concorde on some of the flights it made in from London. So that high angle that you would see the airplane coming in with the drooped nose, while it looked very sexy, there was a reason for that high angle of attack, because that's what's needed when the airplane was flying slow, let's say at about 175 knots, and the droop nose so that the pilot could see the runway. We're not going to have any of those issues with the Aerion AIST.
You're getting, the questions are getting even more technical. What is the fuel tank capacity? Enough.
I'm sorry, I really can't remember that, but it's certainly enough to go 5,200 miles, 5,400 at long range, 42 at supersonic.
There's a couple of questions about, do you think that airports will be ready by 2025?
They're ready now, actually. We presented to an air traffic controllers symposium in Miami 2 years ago, actually, and we showed them data that we had on the turning radius of the airplane, the length, the width, the height, and so on. Not the height of the tail is that important, but, and the general feeling was the runways that we're going to be using at full weight. The airplane will, with full weight sea level, maximum takeoff weight sea level would be 7,500 feet. So those airports that have 7,500 feet or more would be capable of accepting the AS2.
And pilots, what about sourcing pilots? Does it need any special certification?
No, going back to the comment I made about the engine and not wanting different techniques to choke the air going into the engine at supersonic speed, we want the airplane to be simple and easy to fly. We don't want a requirement for ex-fighter pilots or supersonic bomber pilots. This is an airplane that you'd be able to get out of current wide-body business jets, do a 3 or 4 week course depending on how it goes with the FAA and fly this airplane.
More questions. How many do you expect to sell over the next 20 years?
We've been doing market analysis every 2 years using JetNet IQ in the United States, as well as one of the 2 other companies who have done, let's say, quiet market research. We believe there's a market for 600 airplanes over a 20-year period, so on average about 30 airplanes a year.
So there's 600 airplanes, supersonic airplanes. There's lots of companies announcing supersonic aircraft, and there's a lot of noise around the sector from new entrants. Any comments on why you'll be the first?
Really, it's 2 things. Number one and primary is the engine. They're just not easily available. As I mentioned earlier, we searched many years for the right engine. And the first challenge that any other supersonic aspirant would be is finding the engine that will work for their airframe, that will meet all the various criteria, economics, noise abatement, ecological issues. The second is a developer. Now, an existing OEM, of course, could take on a project and bring a supersonic airplane to market, but up till now, none have been announced. So it leaves us and a couple of other aspirants, and they have the same challenges: engine, developer, and of course money.
Someone's asked about how the AS2 compares with Boom. What's your differentiator?
I think you just have to read the specifications of each of the airplanes and make your own mind up. I can't talk about Boom, and I think that Boom is going to be an airliner. They're talking about speeds in excess of Mach 2. I think there's another one that is talking about speeds of around 1.6. But it's the same challenge for both the aspirants. It's about the engine, and Aerion has broken the engine barrier with the selection of the GE.
Why are existing OEMs, or do you expect competition from an existing OEM, is one question.
I think there's probably an inevitability. We'd like to think that Aerion is going to be the first because of how far along the development program we are. Supersonic development is a little bit difficult to keep quiet, and that's a double entendre, of course, but it's difficult to keep quiet, so we're not aware of a current manufacturer who is planning a supersonic airplane.
And going back to the questions, you've got so many technical questions, I might get you to answer these later during coffee, but let's go with the final question. Given what happened with Concorde, do you get pushback from customers about confidence about flying supersonic? Are people scared of it?
No, I haven't had pushback about being scared of flying supersonically. I think, and again, those of us who are young enough to know the Concorde incidents, every accident that ever happens is a culmination of many things, many factors. It wasn't so much airframe design or inefficiencies or unsafe operations of the Concordes that crashed, but eventually it did lead to mishaps and cancellation. But I think the primary function of Concorde not flying any longer was uneconomical, and the airlines didn't appreciate how much people would actually pay to fly supersonically.
Any questions from the room? Old school questions, we have a mic. Okay, finally, with the votes in the audience, would you like to see a supersonic business jet flying? 95% of the audience says yes, which tells us that 5% of the audience is existing OEMs.